Hello everyone, welcome back to my computer project. So last week I said I was going to be making a test board for the RAM so that I could easily just build the RAM and test it without having to build a whole circuit on a breadboard to do it. So this is the test circuit. It's a little bit janky. So basically here we have the 16 lines which select the bit, and yeah, you can use these to disconnect them, which sends them high, which means you're selecting that bit. These are for the, sorry, those are bytes. See, these are for each bit. So there's 8 bits here, but there's like an on and off state. So here we have the on states and the off states. So these will always, so blue will always be the inverse of green. And this little wire here is, because I couldn't figure out a decent way to add in switches. I have this little wire here which you can just press against the lines to switch them. Oh, and it just disconnected. Maybe I shouldn't have used a solid core wire. Oh well, I'll have to get another wire out for that. There's a wire I can use. I need a... There was literally a wire here a second ago. Where's it gone? Maybe this will do. I pulled this out of something. This will do. Oh, crikey. Here we go, look. Hopefully that just plugs in there, and voila, we have a way to connect and disconnect that. Actually, maybe if I stretch that out, that would be a slightly better connection. This one here. What was this one? This was from an old... Christ, what is that made out of? That is solid as... Right. There you go, that should be slightly better. So I can use this, right, to change the value of the bits. And it's set up in a way that it just slots straight into there. So I can do that, and I can put power to here. Power is transferred to there. So that's like a super simple way to test it. You'll also see on the RAM board, I also added these transistors and resistors. This is the setup to make sure that when you're the bits are directly connected to ground when you want them to be, and so it's either 5 volts or 0 volts, and not like when it was going through the addressing board. There's a diode in it, so it's not quite to ground. There's like a little bit of resistance, and there's a voltage drop, and yeah, it doesn't quite connect it perfectly. So I did actually, so once I did this, I thought, oh, that'll work with the addressing board now, but it didn't. Well, it did, but it also didn't. Basically, it did send it high and low correctly, but it happened so fast that for a brief period of time, multiple bytes are selected, so it's actually writing to both bytes at the same time, or trying to read both. And sometimes if you're reading both, it will write the value of one bit to another bit, and it was just all wrong. Now, because like the way my system's set up, it's nothing's latched. There's no actual latches. It's all sort of relies on something being on, then being off, and it doesn't have any logic to have like doesn't store data in between those two states. So it's only got 2 states. It doesn't have a switch anywhere. So the way that affected this was that I had to put these capacitors here, so that when it's switching for a brief period of time, this will keep it, the capacitor will keep that line low. So when you're switching, both lines will go off, then the other one will come on. This means that things aren't overwriting each other, and you're only selecting one bit at a time. This does slow it down a bit, but it depends on the instructions how quick this actually needs to be. There's 6. What I've got in the instruction set so far, there's 6 cycles in the instruction cycles. So it only needs to be, it can be about 6 times as slow as the actual clock, and it will be fine. But I might also change this later to actually include another line, which I can have like just a capacitor on its own and forget all this. And what that will mean is that I could just hold one line low for a little bit longer, which will cause all these to be off until it comes on, then the correct one will be on. But that's neither here nor there. it does work with the capacitors. I need to put them along here as well, and means I need to undo all that and fix it. But anyway, let's test this board. So which one of these was power? This one was power, I think. This one was ground. And nothing's selected at the moment, so all these lights should be off. Yep, they're all off. And if I select a bit, I select a byte. So you can see there's they're all lit up because it's not perfect, but you can see the blues are lit up a lot more. That means that there's a 0, 0 stored in there. If I select another byte, see we have a 1 there, so it's 1, 0 or 1, 0. You can count it. You can count it either way. Yeah, so it's not perfect in that it does slightly display one of the bits. That's because the way a bit is stored is there's a lot of resistance in there. So it uses very little power, which was the goal because I'm going to have a lot of this, but there is a little bit of residual on the bit that's actually off. So that is what causes that. So when I'm reading right in memory, I'll have to be aware that there's going to be a little bit of residual memory somewhere else, and I could just set a I don't know, a bias or a tolerance of how high it has to be before we can read it. Yeah, so I can select all these different bytes. I've got 4 of them tied up at the moment, and so we'll go back to the first one because that was a 0, 0. And if we use this line, we can. How does it work again? So yeah, we can use that. So we can set that to 1, 1. Now if we come out of that, go to something else, you can see that's still got its value. Actually, hold on. Where's that? There we go. That's the 3rd byte and the 4th byte. There's that. But if you go back to the first byte, you'll see it's got this value we saved to it earlier. So yeah, that's how my test board works. Pretty simple. It just plugs in and unplugs. This is a bit precarious. It's not quite on there solidly, but it's okay. But what this will mean, and this is done, right? Other than these bits here, but there only actually needs to be one of these lines on here because this is just the board select. So that will have its own little bit of logic here that dictates whether any of this is working at the time. So yeah, I don't actually need that on here, but I'll add something later. So I don't know. I don't think I need to, but I don't know. We'll see. But yeah, it works. So this will work on a completely finished board. So it can read all 8 bits, or it can read out of 16 bytes. Sorry, my dog is whinging. Shush. Right. Anyway, yeah. So that's that, and that will enable me to create these boards a lot faster. I mean, I'll only need 16 bytes for the time being, and I'm going to move on to doing the controller logic and all that stuff. But yeah, that will help me finish this either way. But yeah, thanks for watching, and I'll see you later.